Okay, so right now I'm looking at the very first part of 4.1.3 upper and lower bounds. So I've already done part of this. Number 1 asks us to construct a scatter plot on the graph. And so that's what these blue dots are. The blue dots are the scatter plot. Number 2 asks you to construct a line of best fit. Remember that it's a line that gets as close to every point as possible. This is my line of best fit. Yours might be a little bit different. That's okay. From there, I ask you to make an equation modeling this data. Remember, our B is our starting point. So for me, my B is at 0. Your M, you need to make a sloped triangle, picking 2 nice points. So I'm going to choose these two. My change in Y goes up by 5s on my graph, so that's 15. My change in X goes by 3s, so that's 1, 2, 3. So my slope is Y over X, which gives us 15 over 3, which simplifies to 5. That means that our equation for this line of best fit is Y equals 5 times X plus 0. On number 4, it asks you to find the residual for all points from the scatter plot. Remember that the residual is actual data minus the estimated data. So I made a table to answer number 4. So this is the actual height. I just took this information from the card that you were given, card number 1. Okay? So I copied this information right here down into the actual height. The estimated height is the number that we get from our equation right here. So my estimated height for this, I would do 5 times 0, and then plus 0. So I would get 0 here. Then I would do 5 times 2 plus 0, which is 10. And 5 times 4 plus 0, which is 20. So on and so forth. From there, my residual is just my actual height, right here, minus my estimated. We know that because it tells us right here. Therefore, my residual is 0 here. 10 minus 10 is 0. 15 minus 20 is negative 5, and you can do the rest. Then, so we've done all of that before. Number 5 is the new part. This is all about upper and lower boundaries. So, you need to find 2 lines called the upper bound and the lower bound. And these are the process to do it. If you can understand this on its own, you can ignore this video. If you don't, just watch. So, part A says, which point was farthest away from the line? Circle it on the graph and find the residual below. So for me, the farthest point from my graph is one of these two. I believe they're actually the same distance, so I'll just circle this one. Hold on for a second. I'm going to circle this point. And so to find the residual, it's actual minus estimated. So my actual data for that point is right here. So 15, my estimated is 20, and I get negative 5. So my residual is negative 5. So the point that's farthest away is 5 underneath the line. So now it says, in a different color, draw a dashed line that goes through this maximum residual point. and is parallel to the line of your model. And then an example is shown below. So this is our example. So all we're doing is drawing a line that's parallel to our estimated line of best fit that goes through our highest residual. So I'm going to draw that line right now. So I circled the point that's our largest residual, and all I have to do is draw a line that goes through that point that's parallel to the line of best fit. And you want it to be a dotted line. So this is my lower boundary line. If your largest residual is above the graph, then you would make the upper bound first. But this is the lower bound because it's lower than the actual graph that we made. Now, part C, you can read it on your paper, asks us to draw another dashed line that's on the other side of the model and is the same distance away as the first dashed line. So here's what that means. So my biggest residual is this point right here. This is 5 underneath the graph. Then I'm going to draw my upper bound. It has to be the same distance as this, except above it. So instead of 5 below, I'm going to put a little point that's 5 above. And then I'm going to draw a line that's parallel to my line of best fit that goes right through that point. And you want it to be parallel to your line of best fit. We know that parallel means that it's like the same slope. They go right next to each other without touching. So I now have drawn my lower bound and my upper bound. Okay? And then you need a number, part E asks you to create a range of values for the possible height of a human with a forearm length of 20 centimeters using your graph. So we need to estimate for 20 centimeters. So that means that we need to go over 20 centimeters. So 13, 14, 15, 16, 17, 18, 19. Oh, we don't get to 20. So let's cross this out and actually do it for 19 centimeters. So we have to, or let's actually do it instead for, let's do it for 15 centimeters. So let's look at part E for 15 centimeters. So part E is asking us to find the range. Here's how we do that. So we go over to the 15 centimeters, which is right here, and then we go up. The lowest point is the smallest that the human height could be. The upper point is the highest. So if I keep drawing my graph, sorry about that. Then a human height at 15 centimeters can be between 70 and 80. So the height in inches of a human with a forearm length of 15 inches, we go up. Sorry, I didn't see that. We go up. The lowest point is 70. The highest point is 80. So for letter E, when it asks me create a range of values for the possible height of a human with a forearm length of 15 centimeters, we would say between 70 and 80 centimeters. And again, I got that because I went over to 15, went up to the lower bound, which is at 70, and the upper bound, which is at 80. And that is that.